Hey guys, so our next lesson here is going to be solving systems of equations. So we know a system of equation is just two equations that we deal with at the same time, right? But solving systems of equation by substitution. Okay, so it's going to kind of be like method number 2 out of the 3 methods we're going to talk about. If you guys remember last class, we talked about solving systems by graphing, right? And simply we just graph the two equations, we'd find the point of intersection, and that would be the solution, right? So substitutions is another method we can use when, one, maybe we don't have a graph to actually graph our equations on, or two, if they're kind of set up in a different way, which would make it difficult for us to graph in general, okay? So what you guys can do, if you haven't already, just write down on a separate sheet of paper, title your notes, solving systems by substitution, and then example 1 with the following 2 equations. Okay, so maybe pause the video now, write those down, and then you can hit play. And let me silence my phone here. Okay, so notice how both these equations here, they're both in slope-intercept form, right? When we say slope-intercept form, that just means the y's are completely isolated. Okay, so you guys would think to yourself, all right, well, if I had a graph, I can just easily graph these two equations and find the common point of intersection, right? So the problem is we don't have a graph right now. So we can use this idea of substitution to go ahead and solve for x and y. So since y is by itself in both equations, is it fair to say that y is equal to itself, y is equal to y? Right? And you'd say yes, because it's the exact same variable, right? So all that means is I can take what y is equal to is to the first in the first equation and set that equal to what y is equal to in the second equation. So I can set up 2x plus 2 equals x minus 3. We can go ahead and solve for x, right? So if I know x is on both sides of my equal signs, I only want it on one side. So I can either subtract 2x on both sides or subtract 1x on both sides. I'll just go ahead and subtract the 1x. We can keep x positive. So 2x minus 1x gives me 1x plus 2 is equal to negative 3. And then I'll just subtract 2 on both sides to get x is equal to negative 5. Okay, cool. But remember, we need a coordinate point for this. When we did solving systems by graphing, we had a coordinate point, an x and y value for our solution. So I currently have the x. Now I just got to figure out the y. So I can take this value of x is equal to negative 5, and I can plug it in for x in either equation here. It doesn't really matter which one you choose. I'm going to choose the second one because it's a lot easier to work with, right? So I can simply just put that negative 5 in and say y is equal to negative 5 minus 3. Negative 5 minus 3 means y is equal to negative 8. So between x is equal to negative 5 and y is equal to negative 8, I can write my final solution as negative 5 comma negative 8, and that would be my solution. Okay, so I'm going to run through 3 more examples with you guys just so you can kind of get a feel of the types of problems you'll be seeing. Okay, and then that'll be it with notes today. Okay, so if I kind of just give myself some more space here, you guys can write down example 2. And the 2 equations we're going to use are y is equal to x plus 10, and then 2x minus y is equal to 20. Okay, so clearly, right, my first equation is in slope-intercept form. I have y is equal to x plus 10, but my second equation is not, right? But since y is already isolated here, right, and you say y is present over here in the second equation, what I can do is take what y is equal to, x plus 10, and I can substitute it in for that y letter there. So instead of writing 2x minus y is equal to 20, I'm going to write 2x minus, then I'm going to put in parentheses the x plus 10, right? Because that's what y is equal to. So I replace that y that I highlighted there with pink with this expression x plus 10. I'm going to lightly highlight it too. Okay? And then that's equal to 20. Now it's important that you guys put that in parentheses, right? Because you're going to have to end up distributing that negative to both terms there. If you do not end up distributing the negative to both terms, you're going to get an incorrect solution. All right, so what this can simplify to is 2x minus 10 is equal to 20. I can combine my like terms of 2x minus x, which is just x. So I get x minus 10 is equal to 20. And I solve for x just by adding 10 to both sides. So I'm going to get x is equal to 30. Great. Okay, so again, I can take that solution of x is equal to 30 and I can plug it in for x in either equation. It looks like my first equation would be a lot easier, right? Because that's just saying y is equal to, we said x is 30, so 30 plus 10, which means y is equal to 40. So again, I would write this as a coordinate point. My x is 30, so 30 comma 40. All right, cool. Moving on. Example 3. So example 3. So these are the types of problems you're going to be seeing on Delta Math. So it'll be a good kind of review to look at these. So I'm going to have negative x is equal to y, and then x minus y is equal to 4. Okay? So a couple things. One, you can notice how in the first equation, right, that y is by itself. Doesn't matter that it's on the right-hand side of the equal sign, right? All the idea is y by itself? Yes, it is. Okay? So what I can do is I can take what y is equal to, right, the negative x, and I can go ahead and plug that in for y here. So instead of x minus y is equal to 4, I'm going to have x minus, and I'm going to put in parentheses, right, minus x is equal to 4. Now we know, right, back from unit 1, when I subtract a negative, it becomes a positive. So x plus x is 2x. I get 2x is equal to 4. Divide out the 2, and I get x is equal to 2. So I got my solution for x. Again, to solve for y, if I just go ahead and put in the 2 for x there, that's just telling you y is equal to negative 2. All right, so I write this as a coordinate point, 2 comma negative 2. All right, good, good, good. So give everyone a minute just to make sure that they're getting that down okay. And then we have one more example that we're going to do together. Okay. And I'm going to, give me a minute, just need a new separate sheet of paper here. Didn't think I'd be using up all this space. Okay, so new separate sheet of paper coming. All right, our last example, so this is going to be what, example 4? So it's right here. Example 4. And we're going to write down the equations. 2x plus y is equal to 8. And then 2x plus 4y is equal to 20. Okay. So looking at these, you can notice they're both in the same form, right? You can see that in both equations, y isn't by itself. We actually call this standard form. When x and y are on the same side of the equal sign, we actually refer to these as standard form. So it's like x plus y is equal to some constant there, right? Some number, right? Just kind of like the brief introductory to that, okay? Now, typically when you guys see it both in standard form, you'd want to use elimination, right? But since we aren't familiar with elimination yet, I'm going to show you guys a quick way you can be using substitution. Now you can see, right, with the two equations, I have a 2 in front of the x here. I technically have an imaginary 1 in front of the y. I have a 2 in front of this x and a 4 in front of this y. If I wanted to get this y by itself here, right, that I just circled, it'd be very easy, right? Because all I'd have to do is subtract 2x on both sides, right? So I'd do minus 2x, and I can rewrite this equation as y is equal to 8 minus 2x. And now it'd be really easy to solve, just like I did in the other example, right? I would take whatever y is equal to, so 8 minus 2x, and just plug it in for y in the second equation. So I'd take what y is equal to, 8 minus 2x, and just substitute it in for the y right here. So what this would look like, right, is 2x plus 4 times 8 minus 2x, right? I'm replacing the y with what it's equal to, and is equal to 20. Guys, a big mistake I see every single time I teach this lesson is that you guys don't get rid of the y. The whole point of what you guys just did is you're actually replacing the y. So you're taking that y, you're literally going to scratch it out, erase it, whatever, and replace it with what it's equal to, okay? So now I'm just back to my distributive property and solving a multi-step equation. All right, so I'll get 2x plus 4 times 8 is 32, minus 4 times 2x, that'd be a minus 8x, is equal to 20. I can combine my positive 2x and minus 8x to get a negative 6x. So minus 6x plus 32 is 20. I would subtract 32 on both sides. I get negative 6x is equal to a negative 12. Divide out my negative 6, and I get x is equal to a positive 2, right? And all I'll do is go back and take that positive 2 and plug it in for x in either equation. Now, it'd be a lot easier just to substitute it in for the equation we manipulated in the beginning, right? Because y is by itself. So all I got to do is 8 minus 2 times 2, right? So I'm going to do y is equal to 8 minus 2 times 2. I'm replacing, right, that x with the number 2. So it'll be 8 minus 4, meaning y is equal to 4. So I'd write this coordinate point, right, as just 2 comma